Good morning, everyone. I guess we can start. I did put the poll about questions from yesterday's material. I don't see any yes replies, but if anyone has any questions about what we covered yesterday, now would be a great time to ask. Before we start this morning's lesson on workflows and automations. And let's start today on a fresh notebook. You don't have to. I just like it. Makes my life easier. If you don't, you might sometimes get some glitchy behavior, especially if you didn't restart the kernel or anything like that. So if you can do start on a fresh notebook. Okay, so this morning we're going to cover workflow and automation. That means loops, that means functions, and that will mean if statements, so conditional logic things. We'll start with for loops. So that is for when you want to do the same thing several times in a row with slightly different inputs. You can use a for loop. So let's have an example of something extremely simple. So a list of animals. This list of animals, for example. If we just print animals, we'll get the entire list back. But what if we wanted to do something with one of them in a row? We can do is use the for loop construction that is identified by the keyword for. And then we define a new variable, usually with a new name, something you've not used before. That's going to be what's called the iterator variable. So this is the variable that's going to change with every loop. And then the keyword in, and then you put in a list or a generator. These are things available in Python that you can use as the overarching container of things that are going to be iterated on. In this case, we're going to iterate over our list of animals. Then, as you can see, when I hit enter, Jupyter introduced these four spaces, this indentation. Indentation is very important in Python. And again, with the reconnecting, sorry. And if you don't, if you don't have the correct indentation, you'll get errors. So you'll need to pay attention not to mix your tabs and your spaces. Otherwise, you will get errors. And you'll want to have the same level of indentation inside the entire loop, for example, or inside a function that we'll cover later, that kind of thing. In this case, let's just, on each loop of our for loop, let's print the iterator variable that we defined, creature. And what we get is we get each of the 5 animals, one of them in a line. So how could we use this to our advantage? So for example, we don't have to print just the loop variable. We can do other things. For example, so you can do something like for creature and animals. Then we can use the plus sign to add a string variable, which the pictures is, because all of the items inside this list are strings as well. Then I'm going to do one more thing, which is outside the loop, and notice that I'm now on the same level of indentation as here, so I'm now outside of the for loop. I'm going to print exactly the same thing here that we had inside the loop, just to see what happens to that loop variable outside of our loop. As you can see, we print 5 times inside the loop, and then outside the loop, the value of creature is saved. So you can access the loop variable outside of the loop, although that is usually not recommended. It's definitely not best practices. You shouldn't count on that being the case, and in certain situations it might not be. So you're best avoiding it, but it can happen. So try to avoid reusing the same variables inside and outside of loops so that this doesn't catch you in the case that you were trying to use a variable that you thought you defined outside, but it was just defined inside the loop. Or in the loop construction, I should say, not inside the loop. Does this make sense? There is a very quick exercise about loops that I think we should have a look for about 5 minutes. But if there's any questions about the construction of loops, I'm happy to answer. Here. Oh, the pass. I did not speak about the pass. Let's talk about the pass statement. So if you use pass in a loop, that just means does nothing and go to the next iteration. For example, if I do this, we won't get the 5 prints here, but you'll still get that the variable is hippo because it's still iterated through the entire loop. It just does nothing inside it. It changes the loop variable every time it runs through one iteration, but it doesn't do anything inside the actual loop. So about 3 minutes to do these 2 challenges. Have a look at this first part of the exercise at least. So what happens if you don't include the pass command in your loop? Well, happens what happened up here when I did it unintentionally. Get a incomplete input or expected intended indented block depending on how exactly you ended it. I think if you do this, yeah, we'll get an incomplete input. So that means that Python is expecting something to be inside the loop. You cannot do an empty loop without the pass keyword. So if you want to do an empty loop, that's how you do it. And as for second part of the exercise, so if you want to, does anyone have a solution for this that they'd like to share? Because I think this is an interesting problem if it's the first time you're doing any kind of iterations. Okay, for creature in animals, let's try that. Again, wrong key. So you have a space and then plus creature. I'm afraid it doesn't. So I can explain why. Every time you do the print command, Python adds end line signal. What we could do is do this. So there's an extra keyword on the print method that is the end, what it adds at the end. So by default, it would add a /n, which is a new line command. So this would be exactly the same as we had before, because this is a default. If we change that to be an empty string, you'd get a list without new lines. That's still not what the exercise wanted. We want to separate it by commas. So what we could try is put a comma there, and that gets almost there, but you have an empty comma at the start, which is also not very not very correct in terms of English. We could try at the end, but then you get an extra comma at the end. So you could get creative with having one creature outside the loop and then just looping from the second index onwards, but there's a much easier solution for anything that is string related, and it's not something that we touched yet, but I think it's a good place to let you know about it. So any string object has these join methods like this. And what we can do is pass it the list of animals to the join method, and then before we tell it to use a comma and a space to separate between the items of the list. So what it will return is this without that last ending comma. As you can see, it's a string. It returns a string. We see that by the single quotes. If you really wanted to use a loop like this, I guess you could do it's an implied loop header. So the join method inside uses a loop, but no, it's not really a loop, not the way we define it. -1, I guess. Oh, no, this won't work. This will get a new line as well. Okay. Sure. No, that would work. Yeah. So if you really wanted to use a loop, you could do this. So what we're doing here, this mildly weird slicing, is all the animals except the last one. And we add the comma to it, and then after the entire loop, we print the last one without an extra comma. So it's much more cumbersome just using the appropriate method for strings. This one might be useful if you're trying to do some string manipulation in the future. Okay, any questions about that? Yeah, I cancel him. You might need to do string.join. Let's see. So because join is a method of a class of a string object, you need the string dot before. Anything else? Well, let's try and use these for loops that we just learned about to do some data processing on the survey files that we've been using all day yesterday. First, I'm going to import the OS module because I'm going to need to manipulate files in my disk and create directories and stuff like that. And then I am going to make a new folder inside my data output. Yearly files. Or I run that. Let's have a look here. As you can see, I only have the 2 files from yesterday. I run this. We should have a new folder. There we go. And now if I do the same just from inside the Jupyter notebook, I don't misspell list, get the same list of files and folder that I just created. Now, imagine if you remember from yesterday, the surveys CSV file had a bunch of years, 25 in total, I believe. So imagine that you wanted to save the files of a particular year. For example, what you could do, I'm going to need to import Pandas again. Read the data frame. Okay. So if I wanted to choose to create a new data frame with just a service from 1 year, what I could do, something like this, and we did this a bunch yesterday. So just refresh where the year is 2002. And we should be able to, all of them are 2002, there's a bunch of them. We should look, there's 2029 records, for example. Okay, so imagine we want to save that to the new folder that I just created. We also did this yesterday, using the to CSV, just a little bit of a refresher. To CSV method, and then this and that path of the file I want to use, which is surveys 2002, and then the .csv. And this would create, as created, I'm sure, a file inside my yearly files folder with the new file. Now, this is all well and good, but there's 25 years, and if you wanted to do all of this by hand, it takes a lot of commands. So this is how we're introducing the usage of for loops. Imagine you want to do this for all of the years, or you can do, well, we can get the list of years that we can then iterate through using the unique command, if you remember. So if you do this, you get an array, which is a list, pretty much the same thing, with all the years on the data frame. So then create a for loop that iterates through all of that and writes one file for each year. So first of all, I'm going to try and delete this one, if I remember. I have a clean folder, just so we make sure that everything's working properly. So for each year in the that we just created. So we're now iterating through that list using year as our iterator variable. So that what we want to do is create a unique file name for each of the folders. So we're going to do that using that that plus technique that we saw earlier. So I'm going to start with having data output, yearly files, and then each of the files is going to start with the name surveys. Then I'm going to add the year, but because these are integers, I'm going to convert it to string. Otherwise, you cannot add integer to a string. And then I'm going to add the CSV extension. And instead of immediately saving this, I'm going to run a quick test and instead just print the file name just to make sure that everything is working as I want. So this is a very useful thing to do a lot of the times before you actually run on your data. Do a quick test, either on a small subset of data, or if you can, just print the thing you want to write. Make sure that everything's working as you intend. So if I run this, I expect to get a very large list with data underscore output slash yearly files slash surveys, then the year, and then with the .csv at the end. Let's see, that's what I get. Yes, that is correct indeed. Yearly files, surveys, then the year starts in 1977, and it should go all the way to 2002. That is what I want. So what I'm going to do is copy that, and then I'm going to modify it so that instead of printing, I'll actually write these to file. So I have my file name to create a smaller data frame for each year, service year, which will be service data frame where I select lines by using the year. So I'm selecting all the lines that have year corresponding to the current year that I'm interested in, creating a new data frame on each iteration of the loop. And then I'll use CSV method to write this to file, and I'm using the file name that I define up here as the path that I'm passing to the method. So put some comments on here so it makes sense. And here select. Okay. So now if I run this and if I didn't make any typos, I should hopefully have 25 new files on my folder up here. And then indeed, you can see that they're not all empty, they're of different sizes. So they should probably be all correct, but we can have a look. So the 1986, they are indeed 1986. So I expect them, we could check a few more, but I expect them all to be good. That makes sense. Is there any questions about this? Can I break down the last two lines? Do you mean service year equals service df and the two CSV? Okay, so here service underscore year, this is a new variable, a new data frame that I'm creating from our big data frame that we read up here somewhere. Where is it? Here. So it is here. I can put it here, so it's read on the same cell. So here we read the entire survey CSV, which has 35,000 lines or 36,000 lines or something like that. We 25 years. Yeah, sure, I can do that. Is that enough? Otherwise, I think that's working. Is it zoom enough? Can't go much more than this, otherwise things start to get outside of the window. Okay. Right. So the first thing is we're reading to surveys underscore df the entire data frame that we were using yesterday, which has 35,000 lines. Then inside our for loop that is looping through the years that exist in that survey's data frame, using the unique, it creates a list with the values of all the years that exist, just one time each. Here in file name, we're creating a string that has the location where we want to save each of our files using the year as a unique identifier so that the files don't overwrite themselves. Then here, we're creating a smaller data frame from the large ones, and using the Pandas selection features of, we're selecting all the rows in surveys_df, where the rows have the value of their column year equals our year iteration. So maybe it makes more sense if I do this. If I name these variables slightly different so that there's no confusion between what's a column in the data frame and what's the iteration variable. Does that make a little bit more sense? And then the last line is just, I'm writing this new data frame that I just created to a file, and the path that I'm giving to the CSV method is the path I created here. If there's still something that doesn't make sense, I'm happy to explain again. Lim is asking, why does this raise because if you're just doing this, Python treats this as a string. So just a string year, not the column inside surveys. So inside the selection area, which is inside these square brackets, this would still be considered a string. So this is a comparison of the string year with the variable year that you define up here. That's why it fails. It is a logic comparison. It's not an if statement. But if you want the year column from surveys.df, you need to use this construction. Sorry, I realized my connection dropped for a second. So it's a logic comparison like you would in an if statement, but it's comparing the string and not the column year of the surveys. Okay, so I think we're near a challenge. Yeah, I think I explained why I did this, so that we get different files on each iteration instead of always using the same path, and then the file would have been overwritten. So challenge time. Let's go for 5-ish minutes. Have a go at doing these 3 steps of the exercise, which would be by the loop, so that you're not saving records with null values, looking at how to save a small range of years. That was a hint. And then instead of looping over the years, loop over species and save the files that way. Okay, so 5 minutes until 13 past the hour. Okay, let's have a look at the solution. So the first thing we're asked to do is to don't save any records or any rows that have NaN, not a number, in our yearly files. So I'm going to copy this, modify it, because it's easier that way. So what I want to do is a very simple change. We just need to add drop NA to when we're creating our yearly data data frame. So here, by dropping all the lines with an A, then as we save here, the files will not include those records. Next, asked that we want to look at the data for a given multiple of years. How would we modify loop to generate the data for only every fifth year starting from 77? So we could do a list ourselves of the years we want, but there is a slightly more Pythonic, more automated way of doing that. So if we want to use a step of 5 and we want to check our minimum and maximum values of year for our surveys DF, so we can check values of year on our surface data frame, and then we can use the minimum method. We do the same for max last year. Now we make sure we have everything correct. First year would be 1977, and if we do 2, so now what we can do is with the same loop up here, but I'm going to modify the list of things that we are iterating over, which will be, in this case, we're going to use the range function, which you have touched briefly, where you can give it the first year as the first first keyword. Can you give it last year as the last keyword? Then we can give it a step, which is the step that we define up here as 5. And if we do this, I'm going to make it print the year so that we can double check that it's writing the things we want. It would then also that would be what? There we go. So starting at 77 and then just doing every 5 years. Now you might notice that 2002 is not here. If we want to include 2002, we'll want to add 1 to the last year. Do that. It should also include 2. Then final exercise, excuse me. A final exercise would be, instead of splitting the data by years, how would we go about doing it by species? So it's a very similar solution to what we had here with the distinction of using species as the column identifier rather than year. I am going to create a new directory that is and going to select using the species ID. I drop not numbers, and then I'm getting a list of unique. This gives us a list of the species IDs, not including NaN. Species underscore. Here species is already a string. Sense. But the same idea as with years, but we're just using the species ID column. There's a few small differences, like drop NA here to avoid the NaN row. That didn't happen. Hopefully, if I didn't typo anything, we should have a species file here, and then all of the different CSV files for all of the different species IDs. Does that make sense? Any questions about these three sizes? Okay. Let's get to the fun part then. Functions. Functions are a way to reuse bits of code. So if you see here, we've been reusing the same construct of for loop with creating the file name, and like we have several cells that are pretty much exactly the same with very small differences. This is where functions come in handy. You can define functions, create functions, so that you can reuse them with slightly different variables. We've been using functions or methods from libraries. We've been using intrinsic built-in functions that Python has by default. We can also define our own. We'll be looking now into how we can define our own. So we've been using a lot of prints, for example. Those are Python built-in functions. We've been using a lot of read CSV and to-CSV from Pandas. Those are all functions, and we can define things like that, or on our scripts, or even in Jupyter notebooks. So what is the construction of a function? So I'm going to copy these because there's a lot of text from the course material, and talk you through what it is. As my connection comes back. Yeah, I think we're good. So a function has these DEF defined as the first keyword. So if you see this construction here, this means it's a function. And then the first thing that shows up is a function name. So in this case, the name is very descriptive. This is the function name, but you could call it, I don't know, multiply to variables, or in this, because what we're doing here, you could name it many different things. I believe function names need to start with a alphabetic character, not alphanumeric, but it can have numbers in the middle. It just cannot be the first one. It can also have underscores and hyphens. I believe those are the rules, but you should double check if you need something more exotic. And then inside the parentheses, here we have the arguments. So this would be the things that we pass it. In this case, we passed file name to the to-CSV that it uses internally to save the file. In this case, we have two input arguments, and then we have the colon. The colon means the definition of the function inputs and arguments is over. This is now what the body of the function. So this is where any calculation or anything that the function does will be written. Anything inside the body of the function will need to be indented, like we had for the for loop. Again, you can see here 4 spaces. Again, I'll reiterate, be careful with mixing up tabs and spaces. Python doesn't like that very much. Always use the same. I recommend spaces, but tabs are technically acceptable if you, as long as you use them consistently. Here we have a couple of comments. So inside the body of the function, we are printing the string the function arguments are, and then we are printing the arguments that we give the function without changing them at all. And then we are printing also, this is done inside the function as a parenthetical. And then at the end, we're returning the product of the two arguments, and we are not printing the product, we're just returning it. Return means give these value back to whatever called my function. So that would be the same like we do, for example, here. So these returns a value that we save as service underscore species. So let's have a look at how that works. So if we just call the function with 3 and 5, for example, run that cell first, we see that we print the text from that line. The function arguments are 3, 5. This is then inside the function. And then we see here that Jupyter writes 15 for us. But if you're running this on a script or on not inside the Jupyter notebook, you wouldn't get a return. You wouldn't get an output. So what you need to do is assign it to a variable. And the return, the value that you return from a function will be assigned to the variable. So now if we do this, we can now print the variable. Now the result from that function has been saved on that. Does that make sense? I know that Jupyter sometimes can make these a little bit confusing because Jupyter likes to print things even though normally Python wouldn't. So if the return thing is a little bit, it's important to understand. Something that you might see as well, especially in newer code, is what are called type hints. So you might see here after the input arguments, you might see something like :int, the same here, and then after the inputs but before the colon, you might see this arrow and int. So these are, like I said, type hints. These are hints for any kind of syntax library you have, that this argument should be an integer, that this argument should be an integer, and that the return type, so the thing that we are giving back at the end here, is an integer. These are optional, but they're becoming more prevalent on newer code. So you might see them. If you do, you know what they mean, but you don't have to do them, although they are very useful. Okay, let's see if that made sense to everyone or not. Is another quick exercise. Yeah, this might take a little bit, give you another 5 minutes or so. Have a play, especially with these two, and try and understand exactly what's happening and why. And then we can discuss that a little bit in 5 minutes. If anyone has found anything interesting on the third and fourth subpoint, please do share in the chat while I talk about the first couple points. Then we can. So first is a very simple exercise to change the values of the arguments provided to the function, and then check the outputs. So instead of assigning it everything, I'm just going to print the result of the function call, which is something to do. So let's try first two larger numbers. So if we do that, you still get the print, and then we get the result of the product. That's not very surprising. However, what happens if we do something like So the product of an integer and a string is valid, although probably not what we intended, but it is valid. So you'll just multiply the string 3 times and output that. So be careful when passing arguments around, so that we know that you don't get weird results that you're not intended. Then exercise 2, try calling the function with the wrong number of arguments, for example. Oops. +1. Get that function name is missing 1 required arguments, input argument. It's telling us that, I'm expecting 2 arguments, you're only giving me 1. I don't know what to do with this. This is an error. And for example, what if we do more than 2? Similar, it's telling them you're giving me more items that I know what to do with. I cannot work with this. Then what happens if you declare a variable inside a function and then test to see where it exists? So let's take the definition of the function again. I'm going to modify it slightly. Print. See what happens. And then if you call the function, you can see that it printed that inside the function. That was fine. But now if we try to print right, we'll get an error that this was not, this variable is not defined. So this is teaching us a little bit about variable scope. So a variable that's created inside the function will not exist outside of that function. So you can use it here, and if you do this, it will work. But as soon as Python exits this function, so after this return command is run, this variable stops existing, and you cannot access it. And finally, what happens with a variable that exists both inside and outside? Then what happens if you change it? So I'm just going to modify this again. This was the signed out file. Inside, or changed inside, I should say. If I print both, should be outside. But now if I run our function, ID. Again, sorry. Outside, if I run this, get the print from here that has been changed. And what happens if I print the variable again? It comes back. So we tried to change what's usually called a shared variable inside a function, but that does not propagate outside. So again, trying to highlight a little bit of scope of variables inside functions. Just because the name is the same doesn't mean the object is the same, and you should be very careful about this. I'd say that avoid using the same variable name at all inside functions that you do outside, just to avoid this kind of confusion. If you need to modify something outside from inside a function, you should return it and then outside of the function assign it to the variable that you need. That's probably the better way of doing things. Okay, so let's have a go at turning those for loops that we used for as to save the yearly files. Let's have a go at turning that into a function that's usable. I copy a lot of these because it's just text. Creating here a function called 1 year CSV writer, and select the data per year. This is the same idea that we did above on one of the for loops, but here instead of using surveys underscore df, I'm using all data because that is the name of the variable that I'm using, that I'll be using to pass that data frame to inside a function. Year, and again, this year is the year that I'm going to be passing to the function. File name. Using our friend 2CSV file to write. So if I run that, I could then just make sure that everything is working as intended. Just ask Jupyter to print the help information for the function. So we can see here, tells us the signature, so the first line basically of the function, and then the documentation, the doc string that we have up here, and some other location or what it is and what kind of thing it is, which is a function. Let's try calling the function for 1 year using our big data frame and see what happens. So if I go here to our yearly files, I now have a function underscore service, which is why I used a different name, 2002. So that makes it easier. So I could just copy and paste these a bunch of times with different years, and that would already save me some trouble. But we can be a little bit smarter than this, and we can create a function that loops through all the years and calls this function with the different years, so that it just prints, that writes everything, every different file to our disk. So a function called yearly data CSV writing. In this one, I'm going to pass it the start year and end year of the things I want to write, the years I want to write, and then again the surveys data frame. Just a warning that end year Lorenzo, the video is showing up for me on my preview on Blackboard. So if someone else can tell me whether that's working for everyone or it's just Lorenzo's issue. The audio drops, I've been trying to check what's happening. It seems my connection is not 100%. Apologize for that. There's not much I can do right now. Okay, so yeah, few lags. I apologize for that, but it should be working. At least most of the time it should be working. There we go. So now we're going to use the same construction you used above. So looping over a range of years. Start, and then +1 here, because otherwise end year is exclusive. So we're adding 1 to make sure that we include end year. And what we do here is we can call the function that we created above, and we can pass it our loop variable year, and we can pass it the data frame that we get function inputs. Here in range. Okay, so let's give it a test. If I do thirdly data writer, and let's do the entire range, which is 1977 to 2002, and pass it surveys data frame. You'd be able to see here that starting at 1977 all the way to 2002, we have a function surveys files written automatically just by creating a couple of functions and passing the data frame to it. And this is the power basically of programming and creating your own custom functions that you can then reuse at will. Okay. There are a couple of things that I would like to finish before the break, and then during the break you can have a go at all the I think 2 or 3 challenges that are left on this lesson. One of the things I'd like to show you, and then before we break at 11, is what are usually called optional arguments. So far we've been using what are called positional arguments. So we're just passing integers, or in this case, a data frame in, but we can also use named arguments. Something like this. I'm going to modify this function, and I'm going to rearrange the arguments so that the data frame is the first thing we have, and that will continue to be positional. But then we're going to have default values for our start year and for our end year, like this. 2002. There we go. The wrong thing. But it just returns the numbers and doesn't actually do any saving. So now if I do, because we're returning 2 things, we're also assigning 2 different variables when we do the function call. So then if we do something like this, start and end, we should get 1988. However, if we just pass the data frame, the original data frame, without any other arguments, we should not see that it's going to use the default 1977 and 2002. So this is what we did here. We set up a default value. You've noticed before when we use methods from libraries, you said, well, the default is that. Even today with the print statement, the default is a new line, but you can modify it. So this is the same construction as we have here. If you give it a default value, these arguments become optional. They're not mandatory anymore. You can still modify them if you pass values, but if you don't, it will just use the default so that you set on function definition. One caveat there is that if you want, for example, an end year, but you don't want the start year, you need to either write the three arguments like this, or so if you just pass one of the optionals, it's gonna take it as the first one. So it's gonna think it's the start, as you see that. If you want it to be the end, you can name it like this. Just if you just want to pass the end year, you need to give it the variable name. So this is good, but if you then have a data frame with different start and end years, these will not work very well. It will work for just this data frame and not for anything else. So in that case, what you would want to do is to create the minimum and the maximum year for the data frame that you pass in programmatically. You could do that using this example. So you set the start year and the end year to none. So that still makes them optional, but doesn't give them any default integer value. It gives them a null value as the default. And then what you do is you check inside the function if the start year and the end year, if they are the value none, then you get the minimum and the maximum from the data frame. And in that way, you can still have those optional values, but without having them hard-coded, which is always a bad idea. Should be working. We're just passing the data frame. We don't have hard-coded numbers anymore. We're just programmatically checking them and setting them inside the function. Okay, last thing, and we have kind of touched this briefly, logic or if statements in this case. You can check conditions, and we've used these logical comparisons in the Pandas data frames before, but you can use them as flow control inside a function or even outside functions in Python. So if you have a variable that whose value is 5, you can use if to then check that variable against something, or two variables against each other, or any other logical comparison you can think of. And then depending on whether that comparison is true or not, you can then run a different piece of code, for example. So let's check if a equals 0, we can say is less than 0. And here, this bit of code that's indented, again, Python's way of defining code blocks. So if this condition is true, this thing here will run. And if that condition is false, this code inside here will not run at all. So let's just test that. So we set A to 5. A is not less than 0, so we don't print that. We just get the last print command here. So let's set A to -5 instead. A is less than 0, finished. Now, if has a few other keywords that can be useful. For example, we have an else. If the condition is false, then else will run. Yeah. A is not less than 0, so this will run, and then the if block finishes, and we drop to outside of the code block. There's a third keyword that's very useful, which is else if, which in Python is actually just elif. It's shortened that way, and then we can do if a equals 0, print a is 0. Example. If either of these run, then the else will not. Only if none of the conditions above are true, then the else will run. And you can have several elifs in a row. This is not limited to one, although a very long logical network can be confusing sometimes. So let's make it be that false and that should be true. So it should just print that bit. Yes, that is not the syntax. There we go. That is the syntax. So A is 0, so this one doesn't print because one of the conditions above was true. So the syntax is always the same. You start with if or elif, then you have a logical condition. For the else, you don't need any logical condition. The else block will only run if none of the above are true. If the first block runs, the second won't, even if they match. So if I do this, so less or equal to 0, this first block will run and this won't. So we see here we match this condition, we do this block, and then we exit the entire if block. Okay. I think that's it for material. We have 5 minutes. I'm happy to answer any questions. And between now and the break, there are a couple of challenges you can do. So the first one is this one, I think. Yeah, after the optional variables. So more functions, and I'll paste these in chat. Variables, last one, which is modifying function. I'd not like to eat too much into Nathan's time, which will start after the break. I'll answer any questions about any of these challenges. If you, as soon as you have them, post them in a chat or send them to me, I'll answer them. If there's a few repeated questions, I can quickly, once we restart, go over that. But otherwise, I won't do all of the challenges on the recording. The solutions are on the course material. So if all you need is a hint, you can have a look at that. But if you have any questions, just ask. Okay. Nathan, please correct me if I'm wrong, but our break is for 15 minutes, so we'll be back at 15 minutes past the hour.
Yeah, that's fine for me. That seems right.
Okay, so that will be in 18 minutes time, so at 15 past 11 UK time, we'll resume.
Okay, so let's get started with the next section. Just a reminder, if you do have any questions from the challenges that were at the end of Rory's last session, do drop a message in the chat. If there's a lot, we might do them online, but if not, Rory will just send some messages to answer any questions. Okay, so we're going to move on to the visualization section of this course, and we're going to start. Actually, I will just get my screen shared to get started. Cool. So we're going to start by using a plotting library that exists in Python called plot9. So Python has some built-in plotting capabilities using a library called matplotlib, which we'll cover a bit in the next section. But for now, we're going to use this plot9 package. If you're familiar with R, or you've used R at all for any kind of plotting at all, this will look very familiar to you. It's based on something called ggplot2, or the grammar of graphics, which is what R uses. Don't worry if you're not familiar with that, we'll go through it. In terms of setup, so plot9 is not included in the standard Anaconda installation, so it needs to be installed separately. Hopefully you've already done that. I'm just going to put a link to the setup in the chat just in case you haven't, because there are instructions on doing it. But again, put a message in the chat if you have any problems with doing that. We're going to get started. So the first thing, so we came across this a little bit previously in terms of the pandas plotting, but plot9 uses matplotlib for its backend. So in terms of actually getting the plots to display, you're probably going to you might need to use something similar to what I've got there to say to do the plots in line. I'm also going to do this from just a clean notebook. So to import plot9, we're going to do quite similar to pandas. We're not going to import the whole thing. We're going to import plot9 as p9. Cool. Cool. And then we're going to read in so plot9 works on, it integrates very well with pandas data frames. So we're also going to import pandas, and we're going to import our same survey data we've been working on. Okay. So we're going to remove all the NA values just to make our plotting easier, because we can't really plot NA values. So that's got our data frame imported. So when you're creating a plot9 plot, the first thing you need is to create the ggplot object. So we're going to get our p9 library.ggplot, and we're going to tell it that our data is our pandas data frame. So we can just run this as is. We will just get a blank screen. There's nothing useful in this plot. I'm just going to make my screen a little bit. Oops, no, that's the wrong one. Just zoom out a little bit so we can get a bit more on the page. Yeah, mostly we get a blank plot because we've told it what the data is. We don't told it what to do with that data. So we can add more information. I'm going to do this. Okay. So to tell it what to do with the data, we need to add a mapping. So we can tell it what the mapping is. So this uses something called an aesthetics object. So p9.aes for aesthetics, and we can tell it that our x values, we want that to be the weight, and our y values, we want that to be the hind foot length of our creatures that are in our data frame. So if I run that, you can see we don't have any values plotted yet, but we do now have axes added to our data, added to our plot, the hind foot length and then weight along in the x-axis. So the aesthetics are used to define our load mapping, so the x and y values, but also things like the color, the fill, line type, all kind of the visual elements of your plot. So the next thing we're going to do is tell it what type of plot we want. So we're going to, just for formatting reasons, we're going to go into multiple lines here. So in Python, you've got to put these, if you're going to do things along multiple lines, you need to put it in brackets. So we can put brackets in there, then do the indentation like that. And then if I do a new line, so plot 9 adds multiple elements together by using this, you add functions together. How it does this in the back end isn't too important, but this is how we layer up things in our plot. So we can now go, we want to make a scatter plot. So it's this geom point object. So in plot 9, all of your, when you're making a plot, it's used geom objects, but there's lots of different types. One, there's geom point, geom bar, depending on the type of thing you want. So now if I run this, you can see we've now got our data actually plotted using the geom point data. Let me know if I get too small, but it'd be useful to get more of the plot on. So this plus syntax is quite interesting. It allows us to do some quite interesting things. So what I can do down here is I can go I can define a survey's plot here, but then we can down here actually draw the plot. And we can say that we want it to be surveys plot plus our geom point. So that will give us exactly the same plot. But what it lets us do is we could then later on, I create a new cell, we can take our same surveys plot, which contains all our data frame and our mappings, but we say we want to make a different type of plot. We might do a geom bin 2D plot. So you can see this is using the same data and the same mappings, but it's really easy to change the type of plot we actually want to do. So I think we'll pause here to do a challenge where looking at making a bar chart. So I will also you might find throughout this is quite useful in terms of for using plot 9. There's a reference with lots of information. Which will be useful for the exercises. And I will put this over here. So if we go, we'll spend just a few minutes if we can go through the bar chart challenge. So using the same data set. And can you create a bar chart using the plot ID column of the data frame to count the number of records for each plot? The plot 9 documentation for geom bar will be quite useful for actually doing that. I'll give you kind of a few minutes or so to do that. Okay, I think let's go through this. Let's create a new cell. So I'm just going to zero out what's right there. Hopefully that's still readable. I think that should still be okay. Okay, so the first thing we're going to do is we're going to create our plot object. We're going to take a bit of data. And we're going to set up our mapping. Now, as we're doing a bar chart and we just want it to count the number of elements, we only need to specify our x value. So on the x-axis, we're going to do plot ID, and then we're going to set our geom, not geometry object, which is geom.bar. So we can see when we run that, it has our plot ID along the bottom, and for each plot is counting the number of entries in our data frame. So the thing about each of our geom things is they have they have a kind of basically something called stat that goes along with them, which says the kind of default operation they do on the data. Now you can change this, but you'd have to look at the reference for information because some work on some plots, some work on others. So this is using our count stat. That's the default for a bar chart. But we can change it. So we can change it to, like, for example, the summary stat. And then, oh, no, I've made a mistake there somewhere. Where have I made a mistake there? Oh, yes, but because this is a summary, I now need to give it a Y because I'd need to tell it. So what I've done here is I've said, actually, take this Y value, so the weight, I want you to plot the weight, but I want you to summarize it. I want you to find the mean. So there's lots of different, a lot more of this is in the actual references for exactly how you can do that. But the key thing to take away from here is when you create your mapping, when you create your aesthetics, those things are inherited by each of the geom objects that you take further down in your plots. So, and we'll demonstrate this here. So we can take our, let's take our point plot again. And we're going to, so if we run that, we'll see it looks as we would expect. We can also adapt different things about it. So we can change the alpha. So that's going to affect the transparency of our points. And we can change that here in the geom point layer. We can also add colors. So we can make it blue, for example, but we can also make the color map the color from each species to be a different color. So for that, we would duplicate that below. We would remove our color from here. We don't want to specify it in the geom object. We instead want to specify it in our mapping. So in our mapping, we can say the color is going to be dependent on the species ID. If we correct so we've got our data specified, and then our mapping, we've got our X, Y, and then also the color. And you can see it's colored the points based on the species ID, and it's given us a legend at the side here. And we've still got our alpha value, which we're specifying here. So we can also add additional elements using our plus operator. So this can add new chart elements and stuff. So we can change the X label. So we'd have p9.xlab and then say what we want to call it. So this is, again, it's using the same, it's inheriting everything that's come before, but it's making adaptations. So we can see when we run it now, our X label has weight and then our unit G that we've specified. And the same exists for, like, for example, Y lab. We'll change the axis on the Y, the label on the Y axis. Then we might look at our plot and go, okay, actually we want to change the actual scale on the X-axis. So we can add a new thing on here, P9 dot scale X. There's actually a few, so you can see we've got continuous date, date time, discrete, reverse, like all kinds of things that you might want to do. We're going to take the log 10 one. I get that just on Jupyter by double pressing tab, just in case people don't know how to do, haven't come across that yet. And again, we can run that, and we can see our plot's been adapted, and our x-axis is now a logarithmic scale, just by adding that one line there. We can also change the theme of our plot. So plot 9 has some built-in themes. So these are all theme underscore. So like we've got our geom, they're all geom underscore, then our type, scale underscore, then what scale. These are theme underscore. So we could add a black and white theme, which changes our plot like this. I quite like, there's a theme outline, I think it's called, which is quite nice. But there's all, again, the documentation, the reference is actually quite good. If you go to the theme section, it has all the kind of themes you can choose from, and it's very easy to experiment with them. We can also manually alter the themes as we want. So this just theme without the one after the underscore and stuff after it. We can now set all kinds of things that we want. So I did Shift Tab there in Jupyter to open this up. But again, it's all in the plotline reference. There's all kinds of things we can set in here, as you can see, the axis ticks. And yeah, I'd say read the reference to find out everything you can do. But here we just want to set the text equal to this element text object from plot 9. And we just want to change the size. So we want to make our text size bigger. So we've got this text parameter, create this element text object and set its size to 16. And then you'll see we've created our plot again, but all the text is bigger. Again, I'll give you a few minutes for this, but we'll do the bar plot adaptations exercise. Where is the... Oh, there we go. Scroll down. So this bar plot adaptations, which is just asking you to adapt the bar plot you made in the previous exercise by mapping the sex variable to the color fill of the bar chart. So again, you'll be changing your mapping to do that. Can you also change the scale of the color fill by providing the colors blue and orange? Basically, can you change the colors yourself? Again, the plot9 reference will be really useful, but we'll go through that in a couple of minutes. Okay, let's go through this here. So we can start again with our GT plot. Our data equal surveys complete, and then we need to set up our mapping. So X is going to equal to our plot ID, and then we're going to use the fill equal to sex in order to get it to do the fill by that, and then we can create our geom bar object. So if we do that, we get our bar chart with each separated by plots, and then the count for male and then female. If we then want to change the color of that fill, we can use our scale fill, and again, there are lots of default ones here. Some of these are continuous, some of these are discrete. So again, it will depend on your data. But for example, I could just use the grey one and it will do it all in grey. Or we can, as this was asking you to do, use the manual one, where we can then specify blue and orange. Then we'll create our plot. So yeah, there's again this again the reference has quite a few scale alterations you can make. Cool. So moving on. So next we'll look at plotting some distributions. Okay, so I'm just going to copy this out because a lot of this is the same as what we've come to already. So we've got our ggplot, data again, our mapping, species and weight. But this time we're going to create a box plot, which can be quite useful for. So we've got our species ID, we've got our weight, and we're looking at the distribution of those weights for the different species in our data frame. We can also, so the other thing you can do is you can layer these geoms, so you can have multiple chart types displayed on the same graph. So we can do this here by adding a geom jitter. I will say this graph is the exact way this graph works is not particularly readable, so I wouldn't recommend it, but it demonstrates a point for something that you might actually want to do. But here you can see we've got our jitter geom, which is all these points. So that's actually plotting our points along here, so we can see more detail of the distribution. But you can see we've also got this box plot, which I might just up the transparency up a little bit. So it's a bit more visible. You can see it has been plotted over the top. It's not particularly readable here. But there are times where, for example, you might want to plot a bar chart and for some reason might want to have either points scattered on there or a line graph also on the same point, and that is entirely possible. You'll notice each of these geoms, they both inherit the mapping aesthetics that we defined in this ggplot above. You can also manually override this, so you can set inherit AES here is usually true, but if you set that to false, you can, it will at this point it'd give you an error, but you could then set your own mapping and your own data specifically for this geom if for some reason you needed this one to use a different one. I won't go into that in too much detail here, but it's something you can do. So we're going to pretty quickly move on to another challenge, looking at these distributions and again applying some of these alterations and customizations to the graph that we've been looking at. So this distributions one, looking at this box plot, see if can you change it into a violin plot, change the scale, and also do some coloring based on the plot ID of your data points. So again, I'll give you a few minutes to do that. And then hopefully we'll have one more thing to do before lunch. Okay, I think let's quickly go through this so we can finish this before lunch. Okay, so I'm going to take what we've got up here, so we can just base off that. Okay, so the first thing we wanted to do is to replace the box plot with a violin plot. So that is as simple as going in here and changing from box plot to violin. A violin plot is just a different type of plot, which rather than a box plot, which has kind of your median and your interquartile range and then your extreme ranges. I'm just going to turn the jitter off for now so we can see the violin plot more clearly. A violin plot kind of does this. The width depends on the kind of density of your data at that point, so it can help you more evenly see the distribution. So this is kind of quite consistent, long thin. This one has got a bulge at the bottom, suggesting most of your data is there. So it can be a useful thing for visualizing your data. So the next thing we're going to do is we're going to try add some color. So in our mapping, we're going to say that the color is equal to, we need this factor and then plot ID. So what the factor does is it tells plot9 to treat this as categorical data. So yeah, so plot ID is not continuous, so we need to tell plot9 that we want to treat it categorically. So then when we run, oh no, it did not like that at all. What did I miss? Oh, I suspect it's complaining. I suspect it's complaining that the violin plot can't really take colors because it doesn't really do that. Is that the problem? Yes, I think it was. Yeah, so we can't. So this color is sending. Okay, we want multiple colors per plot ID, but the violin plot can only really take one color because you can't have different parts of the violin plot being different colors. That was the problem there. So as you can see, the jitter plot is inheriting our color mapping, whereas the violin plot we can specify a specific color. So this is 0.7, which will be effectively as opacity. I suspect there's different ways you can specify color. You probably can do RGB. You probably can just do string color name in order to set that. Yep, and then there was also the last bit, which was also to set the y-axis to be logarithmic. So we can do that just by, again, adding our scale y log 10. And you can see that's now a logarithmic scale, and all of our plots then adapt to that. I think I'm going to leave the last two sections of this chapter for after lunch, because it is now 12. I don't want to eat into your lunch. We'll go through the rest of plot9 after lunch, and then we'll do a very brief introduction to matplotlib, and then we'll move on to something a bit different with SQL. If you have any questions, do feel free to put it in the chat, and I'll either answer now or kind of after lunch, and we'll see how we go. As in, if you just leave off the jitter geometry, I assume, like this. Is that what you're talking about? Yeah, so that's because so our color mapping here, we're specifying our color mapping per plot ID, but in the violin geometry, we're overriding that. So it's got its own color here, which we're specifying to be 0.7, which is effectively white, I think, would be 0, black would be 1, so 0.7 is just in the middle. So basically the violin plot is overriding the color. Because you can't do a color mapping for a violin plot because it doesn't really make sense. You can't have different parts of your violin plot, different colors. Does that make sense? It's only the jitter plot that is actually using the colors. So if you comment it out, it obviously isn't using them. No problem. Yeah, any other questions? Do ask. If not, I will see you. We'll restart at 1 o'clock after lunch. Go through the last few things.